conversion of benzene to nitrobenzene. It is takes place in the presence of nitrating mixture. So this reaction takes place in a three step. This reaction takes place in a three step. So the first step is formation of electrophile. So in the first step, what happened? Your nitric acid get protonated by sulfuric acid and then decomposes to give nitronium ion NO2 plus, which is an electrophile. So HNO3 react with twice H2SO4, you will get NO2 plus, that is your electrophile. Nitronium ion plus HSO4 minus, twice HSO4 minus, that is your conjugate base, and H3O plus, that is the conjugate acid of water. So this is the first step. Now in the second steps, what happened? In the second step, the attack on electrophile takes place. So that nitronium ion NO2 plus, which is the electrophile. Okay, nitronium ion is the electrophile. So the benzene ring attack on the electrophile and forms sigma bond with the carbon atom of the ring. The resulting cyclic carbocation is stabilized by resonance. So what happened? Your benzene ring act as a nucleophile. So you know that in organic chemistry, the high electron density center or electron rich species always attack. Screen is not visible. I am sharing the screen. Hello student, is the screen is visible to you? Hello student? No? Yes? Can you see my desktop? No? Okay. Let me check the connection. Now it is visible. No? Okay. Hello student, now check, is it my screen is visible to you? आवाज भी बहुत देख रहा हूँ. ठीक है, so there may be a problem of internet connectivity from my side. Let me check. Now it is visible. Yes. No. So ये क्या, मैं मोबाइल से कनेक्ट करता हूँ ना, तो प्रॉब्लम होगा. आज सुबह से थोड़ा प्रॉब्लम चल रहा है, मेरा व्हाट्सअप भी नहीं चल रहा था. ठीक है, तो एक काम करते हैं, मैं इसे ही पढ़ाता हूँ और इसका रिकॉर्डिंग करूँगा. ठीक है, और वो गूगल क्लासरूम पे अपलोड करता हूँ. चलेगा? ठीक है. अभी वो थोड़ा सा पण येत नहीं है, कह रहे हैं तुटत तुटत. ग्रुप क्या? पण रेकॉर्डिंग चांगली असेल ना, नंतर बघा तुम्ही. हां, आता बघा आपल्या हातात नाही ते इंट. हां, शेअर करतो. आता तुम्ही हे बघा, मध्ये जर आली रेंज ना तर तुम्हाला ऐकू येईल बरोबर. ठीक आहे. आता एक कनेक्ट केलंय मी, पण त्याचा काय प्रॉब्लेमच आहे, तर काय करणार आपण, बघा की नाही. ठीक आहे. आय एम कंटिन्यूइंग दॅट. Okay, so we are talking about the second step, that is attack on electrophile. So in the second step, what happened? Your benzene ring. हाँ वही तो, स्क्रीन भी नहीं दिखेगा, आवाज तो आ रहा है, आवाज सुनाई दे रहा है ना? हेलो. हाँ तो एक काम करो. ठीक है. अगर हाँ ठीक है, तुम्हाला स्क्रीन दिसत नाही ना, स्क्रीन दिसत नाही ना. ठीक है. हाँ रुको ना, मुझे तो बोलने दो. ठीक है. अभी स्क्रीन नहीं दिखा दे रहा है ना, तो मैंने नोट शेयर किया है. ठीक है. वहाँ पे जाके पेज नंबर 28 देखो. पेज नंबर 28. Okay, now I have already share you the notes. Okay, I already shared you the notes. You go to page number 27. ठीक है, 27, 28 and see that page. Okay, see that page. Okay, so open the Google Classroom, open that PDF file and go to page number 28. Page number 28. ठीक है. All of you open the PDF and open page number 28. Have you opened that? All of you, have you opened page number 28? Hello students. Hello. Yes. Okay. So the second step is that we are taking the revision. Okay. So in the second step in nitration reaction, what happened? Your benzene ring act as a nucleophile. Benzene ring act as a nucleophile. So that benzene ring attack on NO2 plus. Benzene ring attack on NO2 plus. Here, so first there is a formation of pi complex between benzene ring and NO2 nitronium ion. Then that pi complex rearranges to sigma complex. In a sigma complex, there is a sigma bond between your ring and nitronium ion. So, and when that ring attack, okay, one carbon loses its electron, so there is a positive charge on your ring, and there is a sigma bond between ring carbon and NO2, and you will get an intermediate that is called as uranium ion intermediate. Now that uranium ion intermediate, it is stabilized by different resonating structure. So this is about your second step. Now in the third step. So third step, it is nothing but the loss of proton. So the carbocation ion loses proton in presence of base, that is HSO4 minus. HSO4 minus, it takes proton from that intermediate and you will get the nitro compound. Okay, so this is the two-step reaction in which the first step is a rate determining step. So this is the just a revision at what we had learned in the last lecture. So student, now same in page number 28, I am continuing the topic sulfonation. ठीक है. So this sulfonation reaction, it is nothing but the introduction of sulfonic acid group. It is nothing but the introduction of sulfonic acid group SO3H into an aromatic compound is called as sulfonation reaction. And the normal sulfonating reagents are concentrated sulfuric acid. Then you are also using dissolve SO3 dissolved in concentrated H2SO4, SO3 in pyridine, then chlorosulfonic acid. These are and chlorosulfonic acid in CCl4 or sulfuryl chloride SO2Cl2. These are the different sulfonating reagent which are used to introduce or incorporate sulfonic acid SO3H group into your aromatic compound. So this is the example of sulfonation reaction. Okay, so when benzene sulfur trioxide, it is your electrophile, then you will get HSO4 minus, this is the conjugate base of H2SO4, then you will get H3O plus conjugate acid of water. So this is the first step, formation of electrophile. So in this sulfur trioxide, let me draw electronegative atom, 3 oxygen. Okay, so it is attached to 3 electronegative atom SO3. So this sulfur is electropositive because it is attached to this oxygen. Oxygen is more electronegative than sulfur. So what happened? This oxygen withdraws electron towards itself. And make this sulfur as a electropositive. So there is a slightly delta positive charge on this sulfur and slightly delta negative charge on this 3 oxygen. So due to strong electron withdrawing group of this oxygen, it makes this sulfur as a electropositive. So that's why this sulfur trioxide act as a electrophile in this sulfonation reaction. So this is the first step. Now in the second step, that is step 2, attack on electrophile takes place. Your nucleophile will attack on your this sulfur trioxide. The bond will break. Okay, so this bond will break and the bond pair shift on oxygen. So there is a negative charge on oxygen. So SO3 minus, and when this nucleophile means benzene attack on this electrophile sulfur trioxide, first there is a formation of pi complex. Between your benzene ring and your sulfur trioxide. Then this pi complex, this pi complex rearranges to sigma complex. In a sigma complex, there is a sigma bond between your ring carbon and sulfur, and you will get this intermediate. Okay, so name of this intermediate is uranium ion intermediate, and it is also called as Wheelan intermediate. So it is a positive charge containing species, and it is also called as carbocation, the carbon having positive charge. So this carbon is electron deficient. To minimize the electron deficiency of this carbon, this double bond will delocalize here. To stabilize this carbon, or to minimize the electron deficiency of this carbon. And positive charge shift on this carbon. Now in the next resonating structure, the positive charge will shift on this carbon. Now this carbon is electron deficient. To minimize the electron deficiency of this carbon, this double bond will delocalize here and positive charge shift on this carbon. And so you will get this type of intermediate, and this is the hybrid structure of your this intermediate. Now the third step is loss of proton. So in the third step, what happened? Your HSO4 minus takes this proton, it takes this H as a H plus, and the bond pair delocalizes here to form the carbon-carbon double bond, and it will convert to H2SO4, and you will get this benzene sulfonate. Now this benzene sulfonate takes proton from solvent, convert to H2SO4 convert to benzene sulfonic acid. It will convert to benzene sulfonic acid. It will convert to what? Benzene sulfonic acid. So this is the final product. So this is about a reaction mechanism. So this sulfonation reaction, it is nothing but the introduction of sulfonic acid group into aromatic ring. The common sulfonating agents are concentrated sulfuric acid, oleum. So this oleum, it is nothing but the SO3, sulfur trioxide, dissolved in a concentrated sulfuric acid, that is called as SO3, that is called as oleum. Then SO3 in pyridine, chlorosulfonic acid, ClSO3H, in CCl4, sulfuryl chloride, SO2Cl2. So benzene plus H2SO4 at 40 degrees Celsius, you will get this benzene sulfonic acid and water. So and you can do also sulfonation reaction in presence of oleum. Oleum is nothing but the SO3 sulfur trioxide dissolved in your H2SO4. So the mechanism of sulfonation reaction. So first step is the formation of electrophile. So in the first step, what happened? Your concentrated sulfuric acid, the following equilibrium will takes place, that is twice H2SO4. It will breaks down into sulfur trioxide as a electrophile, HSO4 minus as a conjugate base, and H3O plus as a conjugate acid of water. So this is the first step, formation of electrophile. This is the first step, formation of electrophile. In this step, your sulfur trioxide, it is your electrophile. Sulfur trioxide is your electrophile. Now in the second step, this is your step 2. So in the step 2, attack on electrophile takes place. The pi electron of the benzene ring, it attacks on SO3, which is an electrophile, and the resulting rhenium ion is get stabilized by resonance. So this your nucleophile will attack on electrophile, sulfur trioxide. This is your electron deficient species, this is your electron rich species. So this will attack on this, and you will get this rhenium ion, and this rhenium ion intermediate, it will get stabilized by different resonating structure. So this carbon is electron deficient, so the pi bond will delocalize to stabilize that carbon. Again that your positive shift on the other carbon. Same here, this double bond will delocalize here to stabilize this your electron deficient carbon, and you will get this intermediate. So this is the hybrid structure of your intermediate. This is about your second step. Now in the third step, the loss of proton. In the third step is loss of proton. A proton is removed from the rhenium ion in presence of base. So students, the function of base is it abstract proton. The function of base is it abstract proton, it abstract acidic proton to give benzene sulfonic acid. Finally, the benzene sulfonate ion get protonated to give benzene sulfonic acid. So all these steps are reversible, and the reaction is very slow. All these steps are reversible and the reaction is slow. However, the oleum is used, the reaction is faster, it takes place at a room temperature, and high yield are obtained. So when you do the sulfonation reaction, in presence of oleum, what happens? The reaction takes place very faster reaction takes place at a room temperature also. You do not require heating or a drastic condition. The reaction can also takes place in a room temperature when you use oleum. But when you are going to use other sulfonating agent, it requires high temperature and drastic condition to convert benzene into benzene sulfonic acid. And this, when you are using oleum, high amount of yield are also obtained. Now students, let's see what are the advantages of this H2SO4. So here this H2SO4, it acts as a sulfonating reagent. then already it generates the electrophile. It helps it also act as a dehydrating agent, because water is generated in this reaction, so it removes the water, and it acts as a conjugate base in the last step. So this is about your sulfonation reaction. Hello student. Hello. हा, आवाज येतोय का? स्क्रीन दिसते? स्क्रीन स्क्रीन इज विजिबल? हाँ वो अरे जाएगा ना सब्स्टिट्यूशन ओलियम के साथ। कहाँ पे? वो इसमें दिखाएगा, तुम लोगों ने नोट्स में देखा क्या? वो गया है ना, गया है हाइड्रोजन। हमने SO3 लगाया ना। नॉर्मली बेंजीन को 6 हाइड्रोजन रहते हैं, ठीक है। हमने एक हाइड्रोजन, हाँ हाँ हाँ, तो एक निकाल के हमने SO3H लगाया ना, दैट इज सब्स्टिट्यूशन, ठीक है। नाउ इज माई स्क्रीन इज विजिबल टू यू? हेलो हेलो स्टूडेंट्स, screen is visible to you? No, voice is also breaking. Okay, now can we stop here or move towards another topic? इथं थांबायचं का पुढं काय जायचं? You have to stop ना? ठीक आहे, मग राहू द्या, मग आपण ओके ओके. So when you will get the time on Sunday? Are you free? उद्या किती वाजता? उद्या टायमिंग काय पण? संडे काय NCC आहे? आपण एक एक्स्ट्रा लेक्चर घेऊ ना, बरं की नाही? लवकर संपून टाकूया, तुम्हाला अभ्यासाला कोणी वेळ मिळेल. संडे चालेल ना? ओके, so on Sunday extra lecture will be there, okay, and I will share the link to you. ठीक है. So student, now you can leave the class. Okay, we'll stop here because okay, because of what? Oh, घेतली network issue. Now we are stopping this lecture.